In example 5, we're asked to use synthetic division to find the value of the function that was in example 3 when x is 2. So I've copied example 3, the function that we're looking at, and what we want to do is find the value of this function when x is 2. So the old way to do that is to plug 2 in for every x and do the math. But what we learned in this lesson is that we can also use synthetic division to find the value of f of 2. So I'm going to plug 2 in here, and then my coefficients, remember, go here, and there's a 1 there, so that will be a 1, and then an 8, and then a 28, and then a 39. I didn't have to put any zeros in here because I have x cubed, I have x squared, I have x, and then I have my constant term. So I'm not missing any terms. Remember, then you skip a line and put your equals bar. And the first thing you do in synthetic division, remember, is bring down. So that's a little different from when we're using long division. Now you start your multiplication. So 2 times 1 gives you 2. Then you add down 8 plus 2 gives you 10. Then you multiply again. 2 times 10 gives you 20. Then you add down 28 plus 20 is 48. We're going to multiply again. 2 times 48 is 96. And then I'm going to add down 96 plus 39 actually gives you 135, which is our remainder. And if you remember from the remainder theorem, what it tells us is if a polynomial is divided by k, then the remainder is the value of the function when x equals k. So the remainder is the value of the function. So our remainder we got was 135. So that tells us that f of 2 is equal to 135. Notice that you do not change the sign of 2 here because we're finding the value of the function. So you do not change the sign when finding the value of the function. And I guess I should say the sign of C. So this would be our C value. And just to kind of hopefully make that connection, if this is our C value, the factor that goes remember that it has to be in the form x minus c. So in this case, that factor would be x minus 2. But then we actually plug 2 in. So that is when you change the sign. But when you're given c, like we are here, then you don't change the sign. One last thing before I end this video is we're asked then an important question. Is x equal to a 0, or another name for that is a solution of this function? And remember, by the factor theorem, we would have to get 0 for the remainder for it to be a 0 of the function. And since we did not get 0, this is not a solution. So the answer would be no. X equals 2 is not a 0 of the function.